Hi, good morning, everyone. My name is Mark Littlefield. I'm a senior manager at Elma Electronic. Thank you for coming. And I'm going to change things up a little bit. We had a bunch of great speakers yesterday and this morning already, mostly very technical discussions. This will be a little bit lighter, and I'll be doing a little bit more cheerleading, I guess, more than anything. I want to talk about the value of SOSA kind of beyond the U.S. military. And I'm going to give the punchline away that it's about ease of integration. I get asked to talk to a lot of people in the industry because I've been involved with SOSA for a long time. I'm a pretty strong advocate for SOSA, and I get a lot of questions about SOSA. And so I'm doing this presentation because of the questions that I'm getting. In addition, I've got the core of the industry journalistic community here, and this is my chance to get that message out and hopefully then out to the rest of the world. So this is a slide. A lot of people have seen this slide over and over again of what SOSA is. I'm not going to go into it, but what I'm going to do is I'm going to show, where is it? Right here in the middle. What do you have here? You have the Air Force, the Army, and the Navy, all right? So people will often look at this and say, okay, well, you know, I'm a European company working with European customers. Why am I worried about this? You know, I've got the, over here on the, there we are, the, in the domains here that SOSA is focused on. Well, maybe your application doesn't fall in that domain. So again, why would SOSA be important? Just to put some context into that, remembering that SOSA leverages a lot of the previous standards, a lot of the other standards that are out there, probably the biggest being you know, the OpenVPX VDIS65. But there's other parts of SOSA that draw from other sources. But SOSA is the technical standard is a very sizable document. You look at snapshot 2, I'm sorry, version 2, snapshot 1, 434 pages. You look at that and your eyes water and you go, oh my goodness, how could I, you know, be compliant with this or conform it, as the SOSA community likes to use the term. But it covers hardware, it covers runtime environments, it covers the interaction bindings between modules, and then the actual sensor modules themselves. So some of the questions that I'm asked is, SOSA has way too much baggage to be useful for me, so why should I care about it? Or, I have no mandate for SOSA alignment from my customer, why should I pay attention to it? Or, we're European, SOSA is a US military thing, what possible value is it to me? Well, I'm here today to answer those questions, because there is actual value. So, if you take all of that 434, I think was the number of pages, and break it down into a taxonomy, this is what SOSA looks like. You've got a bunch of components that fall into different domains. So I'm going to focus on this domain, the hardware domain. I'm going to talk about it for two reasons. Number one, Elma does hardware, and that's what I know best, it's what I live day to day, so I'm going to talk about what I know. But second, hardware is the most mature. I'm kind of getting up to my next slide. Hardware is the most mature of the modules, of the elements in the SOSA Technical Standard. The first SOSA aligned plug-in card started shipping in late 2018. And we're now in at least our second generation, if not at the beginning of our third generation of products based on the technical standard. And right now, there's plug-in cards for virtually every type of card you'd want, every function. SBCs, switches, GPUs, receivers, other I/O and storage, power supplies, and so on. So there's a lot of components out there to draw from and a lot of experience in using those in the industry. And lastly, there's SOSA-aligned backplanes that are available off the shelf. You know, before SOSA, very often, custom backplanes, even for development, were necessary. And what we're finding now is that's not necessarily the case. And so as kind of in summary of that, hardware really gives us a chance to look at what is kind of the best example of how you can leverage the benefits of SOSA. So before I get into this slide, I'm going to say OpenVPX has been very good to me. I've been living in OpenVPX, you know, what, 12 years now, I think. I was one of the co-chairs of the first version of OpenVPX, so it's very near and dear to me. But it has a fundamental problem. It has a lot of slot profiles. If I did my counts right, 36U profiles and 63 3U profiles. Now that's a mix of payloads and storage and peripheral and switches and other miscellaneous functions, but that's a lot. And nearly all of the payloads, at least, have user-defined pins. User-defined pins kill interoperability and replaceability. They basically form custom pinouts at that point. The problem with that is custom backplanes are then needed to be able to use those pins. And then lastly, board suppliers get vendor lock, because once you've designed something in, if you want to do a technology refresh, you can really only go back to that original supplier. SOSA was designed from the start to try to break that. So how does it do that? By having a limited set of slot profiles. Specifically, if we take a look mainly at the 3U, there's 3 payloads, 3 switches, a radio clock, an RF switch, and then one special one for collecting kind of legacy I/O. That one's special in that it's the only slot profile that allows user-defined pins, but it's virtually all user-defined pins. And there's some rules within the SOSA community about how those are used. 6U has even fewer, 3 payloads, 1 switch, and 1 special for legacy. And so what's the result here? The slot profile is driven more by function. And in my next slides, I'll show you why that is. Boards and backplanes from different suppliers can be used together, and they're easily integrated. Sometimes, entirely different suppliers that have never worked together before, you put things together and they just work. And the big result, you break vendor lock. That's what we were intending to do, and it's what happens. So I'm going to take 2 detailed examples from the 3U. And at first glance, if you're not familiar with this, we call these barber poles. All this is taking a look at a slot profile and kind of breaking out the different ports where they appear on your backplane connector. And you look at this and you go, wow, those are 2 wildly different slot profiles. How can these 2 be interoperable? How do they work together? But in fact, they were very carefully crafted for different functions, and they actually do work together very well. The one on the left is what we call the payload or the compute-intensive slot profile. The one on the right is what we call the I/O-intensive, which is more for, well, I'll talk about the functions. On the left, the payloads, that's where your receiver cards are, your FPGA cards, your GPUs, your heavy-duty CPUs, anything with like a lot of data processing, with a lot of gazinnas and gazadas. That's the profile you would use for that. So that's the function of that profile. On the right, I/O intensive is more your general purpose SBC. So you've got video, you've got USB, you've got serial ports, you've got GPIOs, and so on. But there's a few key features that I want to point out that really makes this architecture work. Number 1 is the data plane. This is an all-to-all communication in your backplane. And it's usually Ethernet, either 100 gig, 40 gig, or 10 gig, depending on your application. But that's generally an all-to-all communication within your backplane. But it's a big pipe, so it's good for moving lots of data around. Next is the control plane. Separated out so that your control messages don't interfere with your streaming data on the data plane. Every board has at least 1 control plane port. Expansion plane, that's used for closely tying together 2 boards, or sometimes more, but typically 2 boards, like a CPU and a GPU, or 2 FPGAs. Now you notice the one on the left, the payload, is twice the size of the one on the I/O intensive. And that is because with the payloads, it's very often necessary to tie, say, 2 FPGA cards together to work in concert on a problem, and you need as much bandwidth as possible between those 2 cards. If you take a look on the left, you've got this large aperture here because there was a need for bringing coax or optical in to be streaming that data into, say, like a receiver or something like that. So you've got a large aperture on the left. Where on the right, you have XMC mapped pins. The XMC allows you to customize your system. Say you want to add a function that's not defined within the SOSA standard, you can add it with an XMC very easily in a standardized way through these mapped pins. So All of this was very carefully thought through to, again, make it as easy as possible to integrate. Another thing that might not be obvious at first is we've taken some steps within SOSA to define a power definition that again, really encourages integration, really encourages the development of a COTS market for power supply units. Specifically, we collapsed the 3 power planes, 3.5, 5 volt, and 12 volt, just to one. Just 12 volt is the only one used in SOSA plug-in cards. Makes it much, much easier to balance. You don't have to balance your power anymore. In the past, you would say, I'm on 2 of these cards, 3 of those, and 1 of these, and oh, this is how much 12 volt I need, how much 5 volt, how much 3.3. Oh, there's no off-the-shelf power supply for that. I got to pay NRE and wait a year to get the power supply that I need for that system. That's gone now. You don't have to worry about it. Go and buy something and it's done. So did I miss anything? No, okay. So I'm going to use one example. It is a US defense example, but it's an example that they're not driven by their customer to be SOSA, but they're benefiting from SOSA. SRT down in Florida uses SOSA hardware, SOSA plug-in cards and SOSA backplanes because they don't build lots of one system. They do a dozen, half a dozen, or a dozen of any particular system, and then they go on to another project, and they do another one and another one, all variations on a theme, but with different combinations of gazinas and gazadas and what have you. So what they do is they've got a couple of backplanes they use, they've got a stable of cards that they draw on to be able to build these systems, and then they customize the front panel to a particular customer's application. And in the last couple of years, they've shipped over 300 systems. And this is from like November, so probably they've shipped since then even more. But they're really leveraging that power of the ease of integration of SOSA to their own benefit, not for their customer saying, you know, you're going to be SOSA, for their own benefit. And that's how they can get these things out into the field quickly and into the hands of the warfighter. So Bill did a great job introducing VNX. I'd be remiss in not talking about it. I'm one of the 2 co-chairs of SOSA small form factors, and so a lot of my week is taken up on VNX issues. I won't go into the details, but the key here, and he mentioned it, but I want to reinforce this, is that we have designed things so that VNX is in 100% alignment with the principles of SOSA. And it's virtually in 100% alignment with the way things are done with VPX. So yeah, some people kind of say, oh, it's just a derated VPX or something like that. In fact, we've got more bandwidth in and out of these cards than VPX offers today. It follows the same data plane, control plane, expansion plane model, the line mate, coax, and optical, the system management, and so on. It benefits in the same way that VPX does in that ease of integration. And in 2023, you're going to see a lot more of this. And again, Bill talked about this a little bit, but I wanted to reinforce. This enables certain applications that you simply can't solve with 3 VPX. Common launch tube is a big one. There's a lot of different applications that use common launch tube. Missile bodies, as Bill said, and CubeSats, small unmanned vehicles. And potentially, this could be very attractive to non-defense applications as well. I'm going to put a little plug in for a study group that I'm working with that we're hoping to wrap up our study in the next, say, week or 2. VITA 85.109, a small form factor mezzanine, is going to be a big complement to VNX. So keep an eye out for that. So, a few notes of summary, a few takeaways that I want to make sure that you go home with. That SOSA is a component specification, not a system specification. There are no SOSA systems, only components made up of, systems made up of SOSA components. And so integrators are really free to use SOSA or not as they like. Sometimes their customer insists on it, but if not, take advantage of it. You know, use it. Don't dismiss it because, oh, I don't need it. You know, take advantage of it. Get your system out into the field faster. SOSA is not an all or nothing proposition. For the plug-in card supplier, it is. You can't have a partially aligned card. But it's not, you don't have to use the entirety of the SOSA Technical Standard to get the benefits of SOSA, is what I'm trying to say here. SOSA is driving the adoption of VITA 46.11 system management. People are finding that, hey, this is pretty slick, and I can do a lot, making my chassis intelligent. I can do a lot of diagnostics and prognostics. I can better sequence my power up so that I don't have to worry about inrush currents and things like that. There's a lot that it brings to the table, and people are seeing that benefit. The use of SOSA components makes prototyping much faster than in the past. No more waiting for a backplane to be designed to do what you want to do. You can buy something off the shelf, prototype on it, and then tweak it to your exact needs when you are ready to go to deployment. So it allows for faster project starts. Faster system integration, that's pretty obvious. Surprisingly, even if you do a custom backplane, those custom backplanes are coming together faster and getting into your hands faster because it's all variations on a theme. We can take an existing design and make this change, that change, and Bob's your uncle, there you've got a new custom backplane where we're not building everything from the ground up every time. So yeah, I mean, I'm asking the journalists here, send that message out into the world. I'm going to continue to preach that when I talk with customers, both domestically and internationally, and just encourage people to use the standard for their benefit. And with that, I'm done. Thank you.